Today we're beginning our unit on linear systems of equations. What a system of equations is two or more equations that share variables. And the solution to a system of equations is an xy pair that makes both equations true. For number one, it says circle all the ordered pairs below that are solutions to the equation x plus 2y equals 8. So a solution is something that when we substitute it in, we get a true statement. So we're going to start by testing 1, 1. So when I put 1 in for x and 1 in for y, we'll have 1 plus 2 times 1. 2 times 1 gives us 2. 1 plus 2 gives us 3. That does not give us a true statement. So we're moving on to negative 4, 6, substituting negative 4 for x and 6 for y. When we multiply 2 times 6, we get 12. Negative 4 plus 12 gives us 8. So we do get a true statement when we substitute in negative 4, 6. So we're going to circle negative 4, 6. Then we're going to test 3, 4, substituting 3 for x and 4 for y. 2 times 4 gives us 8. 3 plus 8 gives us 11. So that one does not work out. Next, we're going to test negative 4, negative 4. When we multiply 2 times negative 4, we get negative 8. Negative 4 minus 8 gives us negative 12. So that one is not a solution. It does not satisfy the equation. Next, we'll test out 4, 2. Putting in 4 for x, 2 for y, we get 4 plus 2 times 2. 2 times 2 gives us 4. 4 plus 4 gives us 8, so that does satisfy the equation. 8 equals 8 is a true statement. Next, we're testing 8, 5. We're going to put in 8 for x, 5 for y. So we're going to have 8 plus 10. 18 does not equal 8, so that is not a solution. Testing negative 1, 3 would give us negative 1 plus 6, which is 5. 5 does not equal 8. Moving on, let's test negative 2, 5. 2 times 5 gives us 10. Negative 2 plus 10 gives us 8. So this is also a solution. That gave us a true statement. 8 plus 2 times 0. So we're testing 8, 0. 2 times 0 is 0. 8 plus 0 is 8. So this also satisfies the equation. Lastly, we can test 0, negative 1. If I put 0 in for x and negative 1 for y, we're getting 0 minus 2, which is negative 2. That does not satisfy the equation. So these are the 4 solutions from these options that all are solutions to this equation. Now this linear equation, if we graphed it, it would be a line. So there are infinite amount of solutions to this equation. So these are just the 4 from this set that satisfy that equation. Number 2 says to underline all the ordered pairs that are solutions to the equation y equals 3/4 x minus 1. So we're going to test all of these same ordered pairs into this equation. So starting with 1, 1, 3/4 times 1 is 3/4, subtract 1, and we get negative 1/4. That does not satisfy the equation. Moving on to negative 4, 6. So I put negative 4 for x and 6 for y. You have to be kind of careful when you're substituting in because an ordered pair is always going to be in the form x and then y with y on the right side. But on this equation, y is on the left side. So you kind of flip-flop them when you substitute them into the equation. So be careful with that. When we multiply 3/4 times negative 4, we get negative 3. Negative 3 subtract 1 gives us negative 4. So that does not satisfy our equation because 6 does not equal negative 4. Next, we're going to test 3, 4. So 3 in for x, 4 in for y. So 3/4 times 3 would be 9/4. Subtract 1, we get 5/4. That doesn't work out. Next, we're going to test negative 4, negative 4. When I take 3/4 times negative 4, I get negative 3. Negative 3 subtract 1 gives us negative 4. So that is a true statement. So we will underline this point. So negative 4 is one of the solutions to this equation. Testing 4, 2. Put 2 in for y, 4 in for x. 3/4 times 4 gives us 3. 3 subtract 1 gives us 2. Next, substituting 8, 5. 8 in for x, 5 in for y. 3/4 times 8 gives us 6. 6 subtract 1 gives us 5. So that one does satisfy the equation. 8, 5 is one of the solutions to that equation. Substituting -1 for x and 3 for y, we would get -3/4. And then I just used a decimal. -0.75 minus 1 gives us -1.75, which does not equal 3. So that is not a solution. Testing -2, 5. 3/4 times -2 would give us -1.5. Subtract 1 gives us -2.5. So that also did not give us a true statement. Moving on to 8, 0. 3/4 times 8 would be 6. 6 subtract 1 gives us 5. 0 does not equal 5. And 0, -1. 0 in for x, -1 for y. 3/4 times 0 is 0. 0 subtract 1 gives us -1. So that one does work out. So we had 4 of them that were solutions to this equation. Question 3 says, which ordered pair is a solution to both equations? So notice right here, we circled and we underlined that one. So that one, 4, 2, is the solution that satisfied both equations. Graph both equations on the same set of axes. All right, so our first equation, all the points that are on there, or not all, but some of the points that we've found to be on that line are circled in green. So I'm going to go ahead and plot these points because they satisfy the equation. I know they are on the line. So I'm going to plot -4, 6, and then 4, 2, and then -2, 5, and 8, 0. And then I'm going to connect them with a straight edge and have arrows on both sides. And then graphing the second one, all of the points underlined in pink are on that line. We know because those points satisfy its equation. So I'm going to plot -4, -4, and then 4, 2, and 8, 5, and 0, -1, and then I'm going to connect those with a straight edge. In number 5, it says, describe how you could use the graph to find the solution to the system of equations. So remember that our solution that satisfied both equations was 4, 2. Notice what's happening here on this graph at 4, 2 is that these two lines are intersecting right there. So that is the one point, one and only point, an xy pair that would satisfy both equations. So the solution, the xy pair that made both equations true, is where those lines intersect, and that point of intersection is 4, 2.